Hello, we will now do our little chapter one review for our end of semester packet. Um, and so chapter one deals with describing distributions, both quantitative and categorical. So let's start with number one, why don't we? It says the scores on a test are shown below. Describe the distribution, including the summary statistics. It also wants us to create a box plot, a histogram, and a stem plot of this data. So to describe a distribution of quantitative data, and this is quantitative data with numbers like this, we would have to cuss. We would have to describe its center, its unusual values, its shape, and its spread. So, but let's go ahead and get the summary stats first. So to get the summary stats, this is what we'll do. Now the summary stats, we've got the mean and median, which describe the center, and then we've got the IQR, the range, and the standard deviation that that describe the spread. All right, so so to get the summary stats, we'll put these in our calculator. So what we'll do is we'll turn our calculator on, and then we will hit the stat button. So we go stat, and then we hit edit, and then in list one, I have put those numbers. So I just put those numbers in list one. And so then what I do to get the summary stats is I'm going to do one variable stat. So I'm going to go stat, calculate one variable stats. And my data is in list one. So I do second and hit the one button, put the list one there. List one is right above the one button. See it? Yeah. And so then in the frequency list, it needs to be blank or it needs to have a one in there. So I'll just leave it blank in this case, and I hit calculate, and that'll give us our summary set. So there's our mean, 73.3 repeating. All right. And then there's our standard deviation. We use that S, 15.79. 5, 6, and then if we scroll down, there's our 5-number summary, our min, our quartiles, our median, our max. And so there's the median, the other big measure of center, that being the mean and the median. And then the IQR is Q3 minus Q1, so it's going to be 88.5 minus 66.5, so it's 22. And then there's the max and the min. You subtract those to get the range. And so to describe the distribution, well, let me go ahead, and so those are our summary stats, but let me go ahead. We need to draw a graph of it, and I'll make a histogram, and certainly you could do it by hand. I encourage you to look back at the chapter one video if you want to see how to do a histogram by hand. It's not hard, but we'll use our calculator, and so we'll do stat plot, and so we'll hit the second button and hit stat plot, and then notice only plot one is turned on, and that's good. We just want one plot turned on. If one of the other ones will turn on, we click on it, turn it off. So we hit enter. We hit enter on to turn it on. Then we scroll over to the histogram right there. There's the histogram. It's in list one. A frequency list needs to say one or be blank. And so now I'm ready to graph it, but I just want to make sure nothing's in the y is equal to. Okay, that's good. If there's anything there, I would clear it because that could kind of mess up my graph. And then I'll hit the graph button, and then just go zoom 9, zoom 9. And so there's my histogram. That's how you do a histogram. And if you hit the trace button, it'll allow you to see the scaling of these. So n is 1, that's how high the thing is. And there's the min and max left and right. You can arrow over to get the other mins and max, and that one has 5 values in it. And so there you go. So to describe the distribution, I've got to cuss in a paragraph. And so what I've done here, so there's my summary stats I just found in my calculator. So these two are the two big measures of center, and then these three are the three big measures of spread. And so there's my graph. Notice I've labeled it and scaled it, okay, with the frequency. There's my histogram. And so here's the main deal, though, the paragraph that is the description. The distribution of scores, make sure to mention the context, is centered around a mean of 77.3 repeating and a median of 84. There appear to be no outliers. I'm going to talk about that in a minute. But there are no outliers in this distribution. And the reason I know that is because a couple of things is because I'd used the formula for outliers, and I'm going to show you. And also I did a modified box plot and it showed no outliers. All right, so it is left skewed. Left skewed means it has a tail going to the left, which this certainly does. And you can clearly see that in the box plot, which I'm fixing to show you how to do. All right, or to remind you, you should already know. All right, the spread is described by these three numbers, the standard deviation, IQR, and range. And so there you go. That is cussing. There's the center. There's the unusual values. There are no unusual values. There's the shape. And then those numbers describe the spread. That's how you do it. That's all you got to do. Now, it also asked us to make a box plot and a stem and leaf plot. So a box plot So the way you could do that is doing it by hand is not that hard, but we'll use our calculator. So we go second stat plot. I hit enter on plot 1, and we will go to the modified box plot. Notice the little dots there. Those are outliers. So if there's any outliers, the modified box plot will show them to us. And so I'll just do a modified box plot of list 1. So I hit graph and then do zoom 9. And so there's no outliers. It's distinctly skewed to the left because the left whisker is a lot bigger than the right, and the left part of the box is a lot bigger than the one on the right. So it's distinctly skewed to the left. So we would certainly expect the mean to be less than the median, which it certainly is. The mean's a good deal less than the median. So that is that. And then there's a stem and leaf plot. Just do the stems. The stems are the tens place and the leaves are the ones place. And so that's the stem and leaf plot. So that's that. And so, all right, that's it for number 1. That's going to be our most involved problem in this video. So number 2, it says show, in number 1, show whether or not there's outliers. Now the formula for outliers are this. So outliers, you just have to memorize this. Outliers are anything less than Q1 minus 1.5 times the IQR, or anything greater than Q3 plus 1.5 times the IQR. And getting off of my calculator is where we got these values. And so Q1 is 66.5 and then minus 1.5 times 22. And then, or anything greater than, our Q3 was 88.5 plus 1.5 times 22. And so this ends up being anything less than 33.5 or anything greater than 121.5. And because there's no values up here that are less than 33.5 and no values greater than 121.5, there's no outliers. And so that's what I said. Make sure and say that, by the way. Don't just find the fences. Make sure and put a less than or a greater than, and then say, since there's no scores that are less than that or greater than that, there are no outliers. And so that's all there is to that. Interpret the standard deviation in context. So the standard deviation is this guy, which once again, we found by using one variable stats. That's just the average amount the points vary from the middle. But you have to stay it in context. So saying it in context, would be this. There's S, our standard deviation, 15.796. The test scores vary from the mean of 77.3 repeating by 15.796 on average. So that's all there is to that. Number 4, because the distribution is skewed to the left, what measures of center and spread are the best ones to describe the distribution? And that is going to be the median and the IQR, because they are resistant to outliers in strong skewness. Those would be, it's not like it'd be wrong to report the mean, but the median is just a better measure of center when you have a skewed distribution. And the same thing, the IQR is going to be your best measure of spread when you have a skewed distribution, because they're resistant. That's an important fact to know. And if it wasn't important, I wouldn't have put it on this review worksheet. All right, so then number 5. So that's all that I did with quantitative data. Now let's look at some categorical data where we got some categorical variables. So this says draw an appropriate graph to show the relationship between gender and their opinion about a statement made by a politician. So it has these group of people, and they were either male or female, and they either agreed, disagreed, or didn't care about this opinion. And so there's the values. When this is a two-way table, whenever you encounter a two-way table, what you need to do is this. You need to create the marginal distribution. So you need to add up all the columns, total number that agree, total number that disagree, total number that don't care, and add up the rows, total number of males, add those up, they add up to 130, total number of females, and those add up to 134. So there's a total of 164 in this study. And in order to make, and so a graph with categorical data like this, we're going to make a bar graph. And since we have two variables, we're going to make a side-by-side bar graph, or we could do a segmented bar graph, but I'll do a side-by-side one. And in order to do that properly, we really need to make percents. And I divided these by row. I found it's not so much the number of males that agree that we're interested in, it's the percent. All right, so what I did is I found the percent of males that agree. So I said 34 divided by 130, so 0.262. So about 26% of the males agree. Then I divided there, 70 divided by 130, that's 0.538. So about 54% of the males disagree, and so forth. And I found the percent that didn't care. And then I found the percent of females 22 divided by 34. So 0.647, or it's about 65% of the females agreed. And then 8 divided by that, and that gives me that, and then 4 divided by 34 gives me that. So I found the percent. You could have also divided by column, but to me, it's more interesting this way. If you divide it by column, then you would have found, well, of those that agree, 34 divided by 50, you'd say of those that agree, that proportion are male, and do it that way. But to me, this was the better way. And so then you just plot these percents. Okay, so I've got males and females. So the males is the open bar, and then the female is the filled in bar. And so then I put agree, disagree, and don't care. And notice I labeled it with opinion. That's important. And so this is the proportion of people. And so then I just said for the males, 0.26 agree. So I went up to 0.26 that agree, and then about 0.54 disagree. So that went up to there. And then about 20% didn't care. So that went up to there. And then I did the same with the females. About 65% agreed. So that went up there. And then 0.235, that's that bar there. And then the 0.118, that's that bar there. And that's how you do it. That's how you make a side-by-side bar graph. And that's the only kind of graph really that you're going to do with categorical data. You can also make a pie chart, but the main thing is a bar graph. And then the next question 6 asks, does it appear they're independent? And we would say they are not independent because they're different. The males are much more likely to disagree and not care, where the females are much more likely to agree. If it was independent, it means the males and females would be roughly the same. Okay, it would mean you didn't matter, which one you picked. Okay, their proportions of opinions would be the same. So in this one, you look and you notice how different the males and females are. So you say it's not independent. Okay, so that is that. Number 7, if you randomly select someone from the table, what's the probability that they're male? Okay, well, there's a total of 130 males out of 164 total people. So it's 130 out of 164. And so that is that. So the probability they're male, 130 out of 64. Then number 8, it says if you randomly select someone at the table, what's the probability they're male and they agree with the statement? Well, male and agree, there's 34 people. So male and agree be 34 out of 164. And so 34 out of 164, that is 0.2073. Yeah. All right. So number 9, if you randomly select someone from the table, what's the probability they agree with the statement given they're male? All right. So given they're male, you can only look at what you're given. You're given just this row, these 130 people. So what's the probability that they agree? And so that would be 34 out of 130. So that would be 34 out of 130, which is 0.2615. And so then, okay. And so then it says, so number 9, this should say in number 5, it should say in number 5, if you randomly select someone from the table, what's the probability they agree given their male? All right, so agree given male, that's what I just found, is it not? Yeah, that's what I just found. So that's the answer to number 9, right? Yeah, okay, good. All right, so number 10. So the last one, it says the weights of 7 dogs are shown below in pounds. The weight of an 8th dog is not shown, it is denoted by an X. What is the largest value X can be and not be an outlier? Okay, so that's just using the outlier formula once again. And so and on the high end, okay, the outlier is anything greater than Q3 plus 1.5 times IQR. And this problem asks what's the most it could be and not be an outlier. So it's anything that is not that in essence. And so when you look at this, you would say, okay, what's our Q1 and Q3? Well, Q1 is the median, the lower half of values, and we got 4 smaller values and 4 bigger values. So the median of these 4 values is the number in the middle. Well, there's 2 numbers in the middle, so you average them. So Q1 is 16, halfway between 14 and 18. Q3 is the median of the upper half of values, okay? Well, there's 4 values there. All right, there's 2 of them in the middle. All right, and so the median is the one that's halfway in between those 2. So it's 31. So therefore, Q3 is 31 and Q1 is 16. So the IQR is 15. And so you plug it into this formula and you would get that anything bigger than 53.5 is an outlier. Therefore, 53.5 is the largest number that it could be and not be an outlier. And that's it. That's your quick little rundown of chapter 1. If you have any questions about that, please send them to me.